Right now, as you watch this, you're spinning through space at over 1,000 miles per hour. Earth has been spinning continuously for roughly 4.5 billion years, without ever fully stopping. No motor. No engine. No outside force constantly pushing it along. So why doesn't something that's been spinning for billions of years eventually just slow down and stop? The honest answer involves basic physics, a violent ancient collision, and something genuinely happening in the news right now. Yes, right now. Earth's spin is actually making real headlines in 2026. Let's get into it. Let's start with the fundamental physics principle behind all of this. An object in motion tends to stay in motion, unless something else acts on it to change that. This is often called inertia, one of the most basic rules governing how motion works in our universe. On Earth's surface, spinning objects usually stop because of friction, like a top slowing down on a table. Air resistance and surface friction constantly drain energy away, until the spinning object eventually stops. Earth, however, isn't spinning on a table. It's spinning in the near-total vacuum of space. With no meaningful surface friction and no significant air resistance out there, there's very little to slow it down. So where did all this spinning energy actually come from in the first place? Earth formed from a massive, swirling cloud of gas and dust orbiting the young sun billions of years ago. That cloud was already rotating, and as gravity pulled material together into a planet, that rotation was preserved. This is the same basic principle that makes a spinning ice skater speed up when they pull their arms in close. Angular momentum, once established, tends to stick around unless something specific interferes with it. Earth's spin also got a dramatic, violent boost from one very specific ancient event. Roughly 4.5 billion years ago, a Mars-sized object is believed to have slammed directly into early Earth. This is the leading scientific explanation for how our moon formed, from debris thrown off during that impact. That same violent collision also significantly affected Earth's spin, adding energy and momentum to its rotation. It's a genuinely dramatic origin story hiding behind something as ordinary as day and night. Here's an important twist, though. Earth's spin isn't permanently constant either. The moon's gravity creates tidal bulges in Earth's oceans, and friction from those tides gradually saps rotational energy. Long-term historical records show this effect lengthens Earth's day by roughly 2 milliseconds every century. That's an incredibly small amount, but scientists have measured and confirmed it using centuries of astronomical records. That lost rotational energy doesn't just disappear either. It gets transferred directly to the moon itself. As a result, the moon is very slowly spiraling away from Earth, moving outward by a few centimeters every year. Now here's the genuinely current, surprising twist making real headlines in 2026. Since around 2020, Earth has actually started spinning slightly faster, not slower, breaking the long-term historical trend. Earth set new rotation speed records in 2020, 2022, and again in 2024, completing days measurably faster than usual. One leading explanation involves Earth's liquid outer core, which appears to be gradually slowing down internally. Through conservation of angular momentum, a slowing core can actually cause the solid outer layers to spin faster. It's the same physics as that spinning skater, just happening deep inside an entire planet instead. There's a second, genuinely unexpected factor scientists have identified too: climate change. Melting polar ice redistributes mass across the planet, and that shift can measurably affect rotation speed too. A 2024 study published in Nature Geoscience found this climate-driven effect is becoming increasingly significant. Researchers now project that by the end of this century, climate effects could outweigh the moon's tidal influence entirely. It's a striking example of human activity measurably influencing something as fundamental as planetary rotation. All of this unpredictability has created a genuinely real, current problem for global timekeeping. Since 1972, scientists have occasionally added a leap second to official clocks, keeping them aligned with Earth's actual rotation. Every single leap second added so far has been positive, adding time, since Earth was historically slowing down. But now, with Earth spinning unexpectedly faster, timekeepers may need something that's never happened before: a negative leap second. This would mean skipping a second entirely, something no computer system has ever actually been tested against. In fact, an official vote in October of 2026 is set to decide whether to abandon the leap second system entirely. The proposed replacement is something called a leap hour, adjusted far less frequently than the traditional leap second. It's a genuinely real, current example of Earth's spin directly affecting global technology and infrastructure today. Quick pause before we continue. Take a guess. Do you think Earth's spin will eventually stop completely at some point in the distant future? Over an almost unimaginably long timescale, yes, technically. Tidal forces are gradually pulling Earth toward the moon's pace. This process, called tidal locking, would take many billions of years, likely longer than the sun itself has left to burn. Let's clear up a few common myths before we wrap up. Myth 1: Earth's rotation speed has always been perfectly steady and unchanging throughout all of history. Not accurate. Tidal friction, core dynamics, and now climate change all cause real, measurable fluctuations. Myth 2: Earth's rotation is now permanently speeding up, reversing the long-term slowing trend for good. Not quite settled. This is a genuinely active, still developing area of ongoing scientific research and observation. Myth 3: Leap seconds have historically both added and removed time from official clocks equally. Not true. Every single leap second added since 1972 has been positive, adding time, until this recent shift. Myth 4: Earth's spin will noticeably stop or change within an average human lifetime. Not accurate. These changes are measured in milliseconds per century, far too small to notice day to day. Let's wrap up with a few fun extra facts. Scientists estimate Earth's day was only about 6 hours long shortly after the moon-forming impact billions of years ago. Dinosaurs may have experienced days noticeably shorter than the 24 hours we're used to today. The record for the single fastest day ever measured happened in the summer of 2024, by a tiny fraction of a second. Scientists use incredibly precise atomic clocks, accurate to fractions of a millisecond, to track these tiny changes. It's remarkable that something as massive as an entire planet can have its spin measured with that level of precision. Okay, let's bring this all together. Earth keeps spinning mainly because there's very little friction in space to meaningfully slow it down. Its original spin traces back to the rotating cloud that formed it, boosted further by the ancient moon-forming impact. Tidal friction from the moon has gradually slowed Earth's rotation for most of its history, transferring energy outward. Recently, Earth has surprisingly sped up instead, likely linked to internal core dynamics and measurable climate effects. This unpredictability has created a real, ongoing 2026 debate over how to keep global clocks properly synchronized. All from one steady, everyday spin that's turned out to be far more dynamic, and far more newsworthy, than it first appears. If this answered a question you never knew you had, that's exactly what this channel is about. So if you enjoyed this, hit subscribe so you don't miss the next one. It genuinely helps this channel grow, and it takes about 2 seconds. Drop a comment and tell me which part surprised you the most. Was it the negative leap second? The climate change connection? Let me know. And if you like this video, go ahead and tap that like button. It's a small click that genuinely helps this channel keep growing. There are hundreds of everyday questions just like this one waiting to be explored. Things happening right beneath your feet that you've never actually stopped to question. That's what this channel is all about. Toggling your curiosity on, one question at a time. One more thing before you go. Tap that notification bell too, so you actually see it when the next video drops. Next time, we're tackling why flamingos stand on one leg for hours without falling over. It's a surprisingly clever energy-saving trick, and you will not guess the mechanism. I'll see you in the next one.